Just bounce to this.
Hey, how's it going, everyone? My name is Brandon Clements, and welcome to this tutorial from Glasshand. It's been a while since we've all kind of checked out some Cinema 4D and Octane stuff, but I got a cool one for you guys today. This is a shader ball scene that I use to test all my materials for clients and projects that we're working on. So what this scene is, it's just a simple piece of geometry that I created, and then it has a platform and some of these thin parts to test some subsurface scattering. But the idea behind it is that you would create all your shaders in this scene and then copy those over into your actual scenes where you're doing your animations and stuff, so that everything looks proper and physically correct here in this scene, and then it should look good in any kind of lighting conditions in your other scenes. Okay, so that's the theory and the idea behind it, but let's jump in and see how we can create some of the shaders and a little bit of Expresso setup. So there's a lot to talk about, so without further ado, let's go ahead and jump in and see what we can do. So right now I have a null object that's just called controls, and you can see it has an Expresso tag that has all of this Expresso on it, and it may look like a lot, but it's not too bad, just because all of these have a rhyme and a reason to it, and I'll show you how we can set that up. And I encourage you guys to download this scene. I'll have it up for 99 cents on Gumroad, and I encourage you to check out what I've done and then add more to this scene, so that when you guys are creating shaders, that you have all the controls that you need and it's working really well for you guys. So that's my hope, is that you'll pick this up and learn some stuff from this tutorial and then just start building yourself. So I'll put this over here on my other display and we'll keep it up and we'll kind of go back and forth, and I'll show you how I created this. But some of the controls, I have the attributes locked here. This cool one is scene scale, and you can see that I have a subsurface shader here on this material. If you watch the candle tutorial that we did a while back, you'll notice it's pretty much the same setup. It's a little more basic than not having all those like textures, some of those actual black and white textures that we'd use for roughness and some of these other things. But anywho, it's pretty simple. So we'll run through this real quick. It's basically just I have my roughness down pretty low, my reflections all the way up, so it's reflecting. And if we go to the index, you can see we could put this at like 1.6 maybe, and we get an updated result here. And you can see that it changes the way that the shader looks dramatically, and that's the beauty of this scene, is that we can just test everything here. So 1.6 will give it kind of more of like a plastic type of look. And then in the transmission, you can see I've tinted it a certain color. Yeah, looks pretty good. Medium, I've added a scattering medium to it and a float texture for the absorption. It's really low right now. And then I actually added an RGB spectrum, so this is giving it a kind of yellowish tint to it, kind of goldish yellowish. And then the scale's at the default. So pretty simple to create a subsurface scattering shader here. And I do not have the fake shadows on, so this is pretty simple. So the cool thing is that when I'm testing the shader, I can set my scene scale. Right now, this blue line, if you can see it, maybe you guys may have trouble on the screen recording, but this is 1 meter. You can see it written right here. So this square is 1 meter. So my scene scale is set to 1 meter. But if I go to 0.1, you can see that it scales down pretty dramatically, and we get some of this bokeh effect from our camera and this depth of field. So you kind of get a sense of it's a real world camera, and if you go into the camera settings, you can see the f-stop is at 1.8, which is a pretty expensive lens, but you could do like 3.5 and that would update. So this would be like taking an actual photo of something that was to scale of this size. And I have my aperture edge at 2, which kind of gives a little more of these blurring out effects here in the background. It looks kind of cool for your bokeh. Autofocus is turned off, of course. Exposure, gamma, vignetting, all this stuff has been piped in here for you guys. So you only have to go to one place to make all your adjustments here in this controls. So post-processing, you can turn it on and off, as well as the camera imager, the bloom power, Of course, you can mess around with this stuff. And then, of course, you can say reset to default, and it will go back. So all this stuff is piped in through Expresso, and we'll be taking a look at how we can do this. But for the time being, I just wanted to show you that everything is to scale in terms of if you were taking a picture of it in real life. That's the idea about it. That's how we can create physically accurate shaders, is if we're paying attention to real-world data, more or less. Okay, so yeah, that's all under the camera settings for your camera. You can also, if you wanted to not have any depth of field, of course you could say the f-stop at 12, which would, get rid of most of that for you. Okay, so set it just like you were working with a camera. Think about that in real world kind of rules. Okay, so yeah, this is subsurface scattering at 0.1. If we go into our light settings, I've set up a backlight. So there is this enable Octane backlight, and if we turn that on, we get to see the effects of what that would be like if there was a light behind this subsurface shader, so that you can make tweaks to it depending on how far you want the light to penetrate into the surface of the shader. Okay, so, and then there's checkboxes to actually hide that from the camera and to hide it from the viewport so you don't see it over here. So we can turn that off. And then we can enable an actual key light here, which will be kind of the same direction as what the HDR is actually putting off. So the key power, we can turn that up, and you can see that it actually filters into the power. So we can set this back to default, and we can disable it if we want to. So, and you can hide it from the camera also if it's showing up in the actual viewport or in the render. Okay, so that's where all the visualization controls and turning lights on and off, it's under the light settings here, and then the on and off. You can also adjust the key size. So right now it's about 100 centimeters. So if you wanted to adjust that in the X and Y, that's where you can do it. Let's actually turn off the environment so we can see this. In Expresso, it's a 2D vector field. So if I turn up the power of the key, maybe somewhere around there, something like that. We can actually see how hard this shadow will get from the key's size. So if I just said it was 1 and 1, you can see that the shadow gets harder, because as the light source gets smaller, the shadows get crisp, and as the source gets larger, say 800 by 800, the shadows get blurrier. Okay, so you can see that in real time, which is really fun to mess around with. Okay, so you can go ahead and you can reset those back to defaults, of course, like all the controls. But this little it says key X and Z position. I wasn't able to change this, but it's actually yeah, oh, I'm sorry, that's right, the key X and Z position. I couldn't change these parameters here, the X and Y. So don't get confused by these over here. Just have fun playing with this. You can take the key light and just turn it, so you can you don't actually have to jump out of your camera to adjust where the light's at. Okay, and then you can adjust the position of how high that key is by this parameter here for the key Y position. Okay, so you can put that really, really tall, and then adjust exactly where it's pointing at. So if depending on how you wanted to use this, the controls should be there for you, and then of course you can say reset to default. Okay, and get it back. So that's a 2D vector field that you can add in your custom attributes with Expresso. So I'll show you some of that stuff before the tutorial ends. So let's go ahead and set all this stuff back to default. We'll disable this and kind of roll this back up. And then we also have geometry lights here in the scene. So if we were to actually go to our environment settings and just turn off our environment for a second, and then we can enable this cylinder. It's an actual cylinder with a black body emission on the geometry, so you can get a different look out of just having this sphere is on the right side here, and you can turn that up, and you can see you can create some different looks for your shaders. So if you want to, and then of course there's color temperatures for all of this. So if you wanted to create a different look, it's all here for you. And then of course you can just say reset to default, and we can get all these back to where they were and disable them, and then actually go up here into the environment settings and turn that on. Okay, so and actually disable the sphere. So those are the geometry lights and the Octane lights. Okay, so that's the light settings. The geometry lights and the actual Octane lights are filtered under those rollouts. Okay, this is kind of cool with the environment. Of course, you can turn it on and off. I have one of Maxime's HDRs in here, and I've turned up the power so I can go up to 3 and 4 and see how bright that actually is in the viewport. And then, of course, I can rotate this around like so. And then I'll load in one that I actually had taken. So let's go into my textures, HDRs, and I actually shot this around where I live, and it's an outdoor scene. And I believe I had 10 stops of dynamic range in this photo. So if you just have it set on 1 and kind of reset it back to default, you can see the sunlight is coming through with these really crisp shadows, and it's looking pretty good. And of course I can just spin this around like so, and of course you can see the effects of how the subsurface scattering shader is working. Okay, so that's pretty cool. I like this feature a lot because it's nice to just throw in a lot of HDRs and see how your shaders are holding up in different environments. Okay, so we've talked about the environment settings, the light settings, the camera settings. This is just a little note. Thank you. And in the shader testing, this is cool because you can just dump your shaders in here and see what they look like. So this is more of like an aluminum, kind of rough aluminum look. And of course I can change that for the bottom too. So if I want to see what it looks like on the bottom, there we go. You can see, you can kind of see through this bottom part because it's really, really, really thin. So you get a different look out of this, right? And then if I wanted to go to my camera settings and actually turn this up so that I don't get any depth of field kind of effects, yeah, you can see right through the bottom of the plate. So depending on what shader you're using, you can see where these get really thin, how the scale of your subsurface scattering material is going to look. So if I was going to put this on both the top and bottom, you can see how those react dependent on how thick the geometry is. So as the light's actually coming through the surface, it's scattering and exiting and causing these certain effects on the pieces of geometry depending on how thick they are. Okay, so this is really, really handy to test. And of course, we're still at our scene scale. It's still at 0.1. So if we go up to 1, you see a much different effect. At 0.1, it looks like my pivot's off just a little bit. So some of the floor's coming through, but that's okay. You know, it's not too bad. But at the scene scale of 1, with 1 meter by 1 meter, you can see just how different the subsurface scattering effects are dependent on real world scale. So you can actually see through the platform and see the texture here. Okay, so that's the kind of basic setup here. Of course, you can turn the logo on and off if it's really annoying you. You can turn it on and off. I always throw the logo on everything, right? So turn it on and off. Of course, you can go in and see exactly how I set this whole scene up. If you go to the layers, and I have this layer called hidden. If you toggle this switch for the actual object manager, you can see how I set everything up. You can see the shader ball, how I actually modeled those out if you really wanted to see that. You know, it's all there for you, but I like to keep it all nice and clean so you're not cluttered with anything as soon as you open it. So let's talk about creating shaders. And there's been a lot of questions about the refractive index site and actually creating physically accurate shaders. So let's throw this onto the top, and then let's bring up the site, because if you go to this refractive index, you may have seen this in other tutorials. If you had used V-Ray or some of the other renderers for these animation softwares, there's been a lot of people using this refractive index, and it's great because it talks about real world properties and phenomena that actually happen in terms of reflections. So right now, I believe it's by default, if you change this shelf to 3D, it's for 3D artists, very cool. You can change to metals or plastics, but we can take a look at aluminum. And if you scroll down to the reflection calculator, you see this number right here. And in the graph, and now I've seen some stuff in V-Ray where people have actually recreated these graphs, and it seems like a lot of work just to get like physically accurate Fresnel reflections and things like that to describe how these are actually reflecting based off the angle of incidence, so the angle related to the camera position. And that's a lot of work, and I don't really want to do that for every single material in my scene, especially if I'm recreating an arc-vis thing, or something that needs to be all physically accurate and working well with lights. So easy way of doing this, it's kind of a workaround, but you can take this number 0.9 or so, and you can actually plug it in. If you set your index to 1, what this will do is actually it's kind of like if you had a glass material, you set the index to 1, you can see perfectly through it. So it causes the entire sphere to be 100% reflective, right? There's no kind of effects going on. So you set that to 1, and then you can go into your specular map or your specular rollout, add a fall off map, and put that number into the normal here. Okay, so that will give you a similar effect. So that way, if you want to work with these real world numbers, you can do that. And it works pretty well. We'll go ahead and let's do an example. We'll create some gold real quick. So we'll go to Create, Shader, Octane Material, and then let's say gold. And then we'll change this to glossy. And we have to go in and change our index to 1. Okay, and you can see it looks completely fake and crazy looking. But then if we go into the specular and we say C4D Octane, we want to do a fall off map. And let's incorporate the number for gold. So if we go up, gold, let that load. At the bottom here, we get this number. We'll copy this. We'll paste this into the normal. And we get kind of a similar effect. Now let's go ahead and try to tint this to a gold color. Maybe something, I don't know, not really good at gold, but if you had some reference material, you could look at that and kind of color pick. So let's save this. R17, you can actually save these color swatches. So I made a pretty big mistake, and I had to actually come back and fix it. So when I was creating the gold material here, one of the things that I was having you guys do was go and to tint the specular color, because we can't use this now with the fall off. This isn't correct, and I can show you a simple example as to why. So let's copy this real quick. Let's just jump into a new scene, and we'll just create a sphere, a new shader, put that onto the sphere, and we'll just leave this at diffuse, which means there is absolutely no reflection. And then we'll just paste this guy in there, and then let's take a look. We'll switch this over to my Octane user and load that up, and then let's add a texture environment. Okay, so as you can see, there is absolutely no Fresnel that is happening here, and we can see why, because these colors are the same. These are being the drivers, and this is the driven black and white fall off map. And I do this a lot. I sometimes confuse myself, especially if I'm on autopilot and I'm just going through and saying things. But this is remapping the black and white, so this doesn't make any sense that the gold colors are the same, and it's remapping to both black and white, so you're not going to see an effect. So if I was to actually make this really dark, then you can see this is more of what we're going for. Okay, right? But this isn't the best way to do it. The better way of doing it is actually just using the multiply. So let's just copy this. We'll go and we'll say multiply. And then if we want to paste this in, Okay, and let's just change this to an RGB spectrum. And you know, we don't have the gold color saved because I had completely shut down and actually left and then come back because I can't let this go with you know, bad information. So anyways, goldish color, and now that is being multiplied. Okay, so that's the proper way to tint a black and white map, and it's hard to see, and it was hard for me to notice when I actually recorded it the first time in the tutorial. But if we take a look at the IOR, you can see that this stays really pretty consistent until the very end here, where it gets 100% reflective. So meaning that gold is pretty reflective in any way that you look at it. Okay, but if we were to actually have an IOR of like plastic, like if we go and change the fall off map to 0.05, there we see a huge dramatic result. And if I was to actually map it with the gold colors the first way in the mix texture, so let's go back and let me show you how wrong it looked. We'll say paste here and then paste the gold color. This is the wrong way of doing it. We don't want to tint it this way. And we're gonna do the fall off map. We can actually just jump in here and nope, sorry, fall off map, and then 0.05 here. And this is the wrong way because you can see that even when we change it to 0.9, right, this is what it was at close to last time. In 0.05 it's not changing. Okay, so those values aren't getting clearly sent through. Now if this was a texture map, so if we use an image texture, say this grime, and then we can, you know, set this to black, or let's just set this one to white, and then you can see you can remap textures this way. Okay, and then you can actually go through and, you know, determine how much contrast you actually want. Okay, so future Brandon had to come in and correct what past Brandon had done because it was wrong. When you actually just want to tint a black and white map, use the multiply. But if you want to remap a black and white image, then you can use these as the drivers, the texture 1 and 2 slot, for the driven texture that's actually loaded into your scene. Okay, the bitmap image. All right, so I hope that clears it up. If you have any questions, just leave them in the comment below. But I'm actually just gonna put this in the middle of the video, so let's catch up to where past Brandon's at right now. Okay, so let's go to the roughness and turn this up to say, there we go, looking pretty good. Let's drag and drop this gold here for the top, and you have a gold shader that's based on the properties of this awesome website. Okay, so this is real world data that we've calculated and know that the refractive index of gold is 0.88. And you can't really do that. That number won't actually go into the index here, so it's kind of a workaround. You can use that fall off map to create the same effect. Okay, so right here in the normal slot, so you can put that number right into there. Then you could come into the roughness channel and then add an image texture, and let's see if we go, maybe have an image texture here. Let's go to my actual textures folder, so I have these general textures, and we'll use this this GW metal. Okay, and there we go. You can see that the shader ball is ready to tweak to your liking. All the shaders should fall on, or all the textures should fall on it nice and how you want it, and then you can, you know, mess with this gamma to boost contrast to get some crazy worn out looking effects on your shader. Now I have some other materials here. It's called mix materials, and if we actually take the the mix wood, and let's put this on the bottom. Okay, there we go. This wood is a mixed material between just this standard wood. You know, we're using the same idea here with the specular map. Actually, if I was to go back and look at plastic, not crystals, plastic, and then we'll go to polycarbonate, and we can take this number, we'll copy it, and we'll paste it. We'll paste it here. We almost get this kind of lacquered plastic look to it. And if we go, I just basically created this material with a diffuse map, and then I copied it, and I went into the specular again and jacked up the number here, you know, so that it's actually very reflective. And this is for the edges, okay? So this is being mixed with this Octane mix material, and using the dirt shader you can get some pretty cool effects based around the angle of the geometry here. There was a plugin that I was using from Paul Everett that's really good, that does this kind of effect. It will actually look at the normals of the geometry, and it will actually create a black and white map. And you know, you can do so much with Paul's plugin. It's really great. I'll leave the link in the description for it. But you know, just as a down and dirty way, you can use the dirt shader, no pun intended. And that will actually, if you invert the normal, you can start to work with the radius of how this is going to show up. So if we actually took, let's see if we could take the plastic and put into that second slot, just so we can see exactly what's going on. Okay. And you can see as I bring up this radius, it's gonna actually flood this bottom part. Now let's put it on the top. It's probably gonna be a lot better to look at if we put it on the top. And then let's put this down kind of low and turn up the strength. And you can see it branching out from these edges here. So you can create some worn edges and different effects with these mixed materials, having a base you know, coat that's like facing the camera, and then your second material here will be the edges based on the normals of the geometry. That's with the dirt shader. Okay, so you can see my settings here, turning that strength up. So if we were to put the wood edges back in, and you can see that it just kind of helps break up that material on the edges here. So it's just a lot of fun to mess around and use this scene to your liking, to get used to shaders and some of the maybe some of the other Octane shaders that you haven't used before. So all of these guys, you can have fun, mess around with them, see what's going on. You can actually bring up the Octane node editor, and you can see how everything is being piped in. And I'll use this Octane node editor in this scene as well. You can find it through Materials, Octane node editor, and this will allow you to just, you know, you have all of your nodes here to pipe it in and see things a little bit easier rather than looking at it in this stack form, as you see here. Sometimes it's a little weird doing so many stacks and getting so complicated, but having this scene allows you to ramp up your complexity, create your shaders, save them here in this scene, copy them over into other scenes, and use them time and time and again. So I really love working this way, and I work this way on most projects just because I can focus on the shading and the textures and how they're actually mixing together, rather than trying to do that all in one scene with lighting. It sometimes can get can get pretty cumbersome. So if your shaders are looking good here in this scene, and you go ahead and create your lighting setup just with like normal, just flat shading in your other scenes, then the theory is that if it looks good and it looks physically accurate here, then it will look physically accurate in your actual scenes that you have laid out. So the last thing I'd like to show is a little bit about Expresso and how I set this scene up so that you guys can go ahead and start editing it to your heart's content, you know, adding controls that you like and giving yourself some more freedom. So I already mentioned before that if you needed to get into this hidden layer, you can actually hit this switch and you will see everything. I accidentally hit the lock. So you'll see everything kind of pop up. But if we actually make this large and we kind of zoom in here to the bottom, there's something interesting that was happening with the scene scale. And the other parameters are just basically taking from the tags, and you can drag the tags in and then start mapping in your custom attributes into those parameters. So you have everything in one place, basically. That's the idea. And I have this locked, so if I click on anything, it won't jump away from it. So let's dive in, like I said, to the scene scale. I think this was the coolest part because if you can understand what's going on here, you can build more onto this scene in terms of Expresso. So you add the tag, you double click the tag, it'll open this window here for Expresso. You get all the nodes, and the scene scale, when I put it to 0.1, the camera actually goes into a different coordinate, and it zooms in, and it actually changes the focal length of the camera lens, or the focal depth, I should say. And that's all being controlled by a range mapper. So in the range mapper, what this is saying, it's getting the actual real number, so the data type. You can see if I hover over the input down here, it says real and real. So those have to actually match, right? Your data types have to make sense. So a real number going into these real numbers here for the range mapper. So of course, the first thing you do is you say manage user data, and this is where you create all of your custom attributes right here. You add groups. These are the groups. You can see the names, short names. And then you add the data that go beneath it. So like scene scale, for instance, it's a data type of float, and then a unit which is real, and you can use percents, degrees, whatever you like. Okay, so that's the unit type is real. It's stepping by 1. I can have this step by 0.1. So if I set this to 0.1, then I hit OK. As I use the number slot right here, and I'm hitting the arrows, it'll step by 0.1 increments. Okay, and the camera is going back and forth from this range mapper. Okay, the range mapper is telling the system, let's bring it up, that at the lowest point of the custom attribute, since it's 0.1, and the highest range of the custom attribute is at a 1, which is 1 meter, 0.1 meter, then the output when it's 0.1 needs to be 367. When it is 1, then the output needs to be 0. Now, what is this actually talking about? It's talking about the camera position of Z. Okay, so let's lock the camera position. Let's go to the coordinates and just look at the position Z and what we had just talked about. Okay, so I'll actually let me get the controls, and I will pop this out, and then let's go back to the camera and let's lock this here. Okay, so everything that I just said at 1, it is 0. And let's go ahead and pop this out too so we can see exactly how it's working. Okay, sorry about that. Let's go back to our camera lock. Okay, cool. So now we can see this all. At point 1, the actual camera position in Z will be 367. At 1, the camera position will be 0. Okay, so as we actually go down to point 1, the Z piping in is at 367. Okay, let's look at the range mapper over here, and this is for the Y. Pop this out, click on the camera again, lock it. Okay, at point 1, the camera position in the Y will be negative 27, and at 1, the camera position will be 0. Okay, because I froze the camera's position. You can see the camera has been frozen. So that 0, 0, 0, it will always go back to this standard position here. Okay? And you just create these nodes. So calculate range mapper. That's where you can find the range mapper. And you just actually pipe them into the attributes that you would like. And you can drag anything into this Expresso window. And when I say anything, I mean mostly anything. Mostly any object into this window. And so, you know, just for instance, you can drag the camera tag in here and then go and remap any attribute, okay, to there. And if you hold Control and double click, it will expand it. So, you know, you move around in this scene just like you would in the viewports, okay? So I won't go through and bore you with all of these attributes. You can take a look at the scene file and take a look for yourself, but this is a great way to save yourself a lot of time because especially if you're working with a client and you know you're going to be editing things, you can rig your scenes up using Expresso and have this one null be your one-stop shop for everything, for all the attributes that you know you're going to be constantly changing. So this was a look at this shader ball scene that I use all the time for my projects, and I hope you guys download it, check it out, and add to it. Really expand upon this scene so that it's your tried and true, always going back and using scene files for your project so that your shaders look as great as they can look. Make them look the best that they possibly can, because it really does help, and it speeds things up dramatically. And I think you guys will know that when you actually download it and start using it. So as long as you lock this attribute window, you can just create materials here in the manager and then dump them in. And if you have any questions, please leave them in the comment section below. I'll try to get to them as soon as I can. Thank you guys so much for taking a look at this. Leave this video a like if you did like it, because it helps me determine what kind of tutorials I'll do next. So thanks a lot, guys, for your time, and we'll catch you in the next one. Take care.